A mile beneath the surface of the Red Sea lies the abyssal plain, a lightless, silent desert where the weight of the entire ocean exerts a crushing, constant pressure. In 2020, researchers aboard the Ocean Explorer deployed a submersible to map this void. For 8 hours, they scoured the seafloor, finding nothing but an empty, muddy horizon. Just before the crew prepared to end the dive, their headlights caught something unexpected: a 20-meter-wide, shimmering mirror resting flat on the seafloor. This was a distinct lake of water, complete with its own shoreline and slow-motion waves lapping against the sand, sitting entirely submerged at the bottom of the ocean. These formations prove that the ocean floor hides pockets where the right combination of temperature and salt creates environments that appear to ignore the boundaries between liquids. Despite its calm appearance, the lake is surrounded by a graveyard. The shoreline is littered with the perfectly preserved mummified remains of fish, eels, and crabs that have been there for decades. Any animal that wanders into these waters is struck by immediate toxic shock. The salt concentration is so high that it triggers violent convulsions, leaving the creature to sink and settle on the dark bed below. This water is also anoxic, containing no oxygen for animals to breathe, and it's heavily saturated with a cocktail of lethal methane gas bubbling up from the Earth's crust. This combination of paralysis and suffocation makes the brine pool a permanent trap, arguably the most hostile environment on our planet. The story of these lakes began more than 100 million years ago. During the Jurassic period, entire seas evaporated, leaving behind massive, thick layers of salt that were eventually buried by the Earth. We find these formations today in bodies of water like the Gulf of Mexico, where those ancient salt deposits still sit trapped miles beneath the modern seafloor. Millions of years of heavy sediment piling on top eventually squeezes that salt, forcing ultra-concentrated brine to seep back up through cracks in the earth. This heavy, warm brine pools in the depressions of the seabed. In a glass of water, salt would just dissolve and disappear. But at these depths, a process called double diffusive convection keeps the two waters separated. Heat escapes the brine 100 times faster than the salt can. This causes the water sitting directly over the lake to warm up and rise away before it has a chance to mix with the heavy salt molecules trapped below. This thermal reaction creates a physical barrier so dense that a submersible can bounce off the surface of the lake like a trampoline. Through this balance of heat and density, these pools remain as impenetrable, isolated pockets of brine sitting right on the open seafloor. Here is the paradox. While the lake is a trap for most, its shoreline is carpeted with life. Giant, ancient mussels and thick colonies of tube worms thrive directly in the toxic haze. These creatures survive because of specialized bacteria living inside the mussel's gills. Through chemosynthesis, these bacteria harvest the lethal methane gas bubbling up from the earth and convert it into usable food for the entire ecosystem. This provides an alternative to the sun-powered world we know. While most life relies on photosynthesis, these creatures are fueled by chemical energy in total darkness. The brine pool is a self-sustaining engine of life, proving that some organisms have adapted to see poison as a primary source of fuel. For over a century, biology was guided by Charles Darwin's idea that life first emerged in a warm little pond on the surface, sparked by sunlight and electricity. But the discovery of chemosynthesis in the deep ocean suggested that life doesn't actually need a sunlit surface to begin. 4 billion years ago, Earth's primordial oceans were salty, rich in methane, and almost entirely devoid of oxygen, conditions that match a modern brine pool exactly. Evidence now points toward the idea that the first life on Earth emerged inside a crushing, toxic abyss just like this one. Finding life in these pools suggests that our search for extraterrestrial biology may have been focused on too narrow a range of environments. Jupiter's moon Europa hides a massive, salty subterranean ocean beneath a frozen crust miles thick. Saturn's moon Enceladus also features an icy shell covering a deep, salty sea. Because we now know that life can thrive on chemical energy in total darkness, the lack of sunlight under those icy shells is no longer a barrier to the existence of life. In 2030, NASA's Europa Clipper will reach Jupiter to begin investigating whether these distant oceans harbor the same chemical signatures we see in our own deep-sea pools. The pitch-black, crushing abyss isn't a wasteland, it's a crucible that teaches us exactly where life can endure.